Hello and welcome to episode number 8 of my Fortnite tutorial series. Today we will continue working on our building system, specifically the building manager, so that by the end of this episode you're able to select different buildings using the specified hotkeys, and we'll also be able to spawn the little preview of our building in the world and set its position and rotation to where our character is facing. Taking a look at Fortnite, you can see that we select different buildings using the hotkeys, in their case F1 to F4. Also, if you're in combat mode and hit one of these hotkeys, you'll automatically go into construction mode. And if you're in construction mode and going back to combat mode, your current preview building will be deleted. However, if you go from combat to construction mode again, your most recently selected building will be selected again. So let's recreate that functionality. Let's go to Blueprints, Classes, and to our building manager. Let's first add a variable of type boolean called currently building ? We will need that later for a couple of events. And now we need to work on some functions. First off, we want to be able to get a widget for a specified building so that we can highlight the widget of the building that's currently selected. Let's call that function widget for building. It only returns something, so it's a pure function. We will need one input of the type master building class reference. Just call that building. And of course it needs one output for the widget, and we will add a second one. So our first one will just be a boolean called success, and then the second one will be our w_building object reference. Let's call that widget. Finding the widget is actually very simple. You just get your building widget and run it for each loop with break. Hook that up to the execution here. And for every element, we want to check whether the building of the array element is equal to our input. Then add a branch by holding B and left clicking. Connect that to the loop body. If that's true, we can just grab the array element and make the local variable called local found and set that on the true path. If we found the widget, there's no need to check all of the other array elements, so we can break out of our loop. And once it's completed, you can get your local found, call isValid, and we will return something different based on whether it's valid or not. So if it is valid, means we were successful, so check that, and connect the local found as the widget. Copy paste that for not valid. So if we weren't able to find anything, success will be false, and the widget will just be null. Compile and save. Before we continue with our functions, there are a couple of events that we will already add here, but implement them later. So add a custom event. Call the first one on start building. Let's copy and paste that and call it start building. Paste one more called change current building. Then we need another one called on stop building. And that's it for now. As I said, we'll implement them later. So let's continue with some functions. Just a little helper function here called get current building info. This will have one output of the type s_building data or info. Let's just call that out. Make it a pure function. Then grab your buildings array, so the classes. Get from it at the selected building index. So the return value here is your selected building class. Then get the class defaults of that and hook up the building data to the output. Compile and save. Then we need a function to select the current building. Give that an input of type boolean called select. Just means we can use this function for both selecting and unselecting of the current building. We first want to see whether we've got a widget for the currently selected building. So drag in your buildings, get from that at the selected index, and then try to find widget for building. Then off of the success, let's add an if statement or branch. If it's false, means we didn't find a widget, so there's nothing to do here. We can just return. If it's true, however, grab your widget and call the select building function of it that is responsible for updating its display, and hook up the select from the input node. If we are really trying to select a building, so if that boolean is true, that also means we have to start building it. Let's add a branch off of that input node, and if it's true, we will just call one of the events we just created, so on start building. Copy our return node for the false and true path and hook that up. Now we're still lacking the functionality to change the building index here, the selected one. So let's add a function called select building by index. Of course, that means it needs an input of type integer called index. We can promote that to a local index to avoid messy wires later. And the first thing we need to check is whether that local index is actually a valid one. So it needs to be in the range of 0 to the last index of our buildings array. And the function you can use for that is called inRange integer. You plug in a value, minimum, maximum. The maximum will be our building's last index. And we will check inclusive min and max. Then let's add a branch. Again, if that is false, there's nothing we could potentially do here, so return. If it's true, however, there is different functionality based on in which state our player character is currently. Because if we're in combat state, we also have to go into the construction state. So let's grab our player character, get his state, the enumeration here, and let's call switch on ePlayer states. If we're in combat, let's set the selected building index to our local index. Then copy your player character and call change state to construction. Later in our change state function, we can actually add the functionality to select the current building widget when you're changing the state to construction. But for now, that's enough for that path here. If we're in construction already, we first have to add another if statement and check whether the local index is unequal or not equal to the selected building index. Otherwise, there's no point in updating anything. Hook that up to the condition. If it's false, just return. If it's true, however, we will first select current building with false. So unselect that, then update our building index to be the local index, and then select current building again. Now with the select being checked, and after that add another return node. Let's copy paste that for our change state here and also hook that up. Okay, compile, save this function. Let's close the functions for now. And in our event graph, we've got our initialize event, and our building manager itself doesn't know in which state our game starts. So it could be that we're starting in construction state and then we would have to select our current building. So to prevent any issues, just grab your player character and the state, then switch on that. And if we're in construction, we will just call select current building with select being checked. That's it for the building manager for now. Go to your third person character. And as I said, we have to execute some functionality when changing the state. Let's actually do that in the update state display function because we already implemented that switch here. Let's add some space for both branches. If we're switching to combat state, that means we've got to get our building manager and delete any current building preview. So call on stop building. And then proceed with showing the current resource. If we're switching to construction state, we want to get the building manager too and select current building with the select being true. Hook that up and after that update current resource, compile and save. Right now our hotkeys aren't actually doing stuff, so let's fix that in our event graph. Now what you could do is just look for the hotkeys and assign some functionality to that. However, we set it up so that you can change the hotkey in your building classes, which means that actually we don't know which keys are used. So what we need is the event any key, and then we have to figure out whether that key we just pressed is used for any of the buildings. So what we'll do here is a for each loop with break, and to get the array you get your building manager and the building classes. So get buildings. Now we've got to check whether the correct hotkey was pressed. So off of the array element, get the class default, grab your building data and break it. Then we grab the hotkey and check whether that double equals the key from our input event and branch, hook that up. True means we have to select another building. So let's grab our building manager and call select building by index. it will be asking you for the index. And since we're cycling through all of our building classes here, the index will simply be the array index of our loop. After we did that, we can break out of our loop, so no need to check the other classes. Compile, save, and that should already be working. So if we go into play mode, we are currently in combat mode. If I hit Q, you will see that F6, so the floor is actually selected right now. There is a white outline, and you see that the empty space between hotkey and actual icon is reduced. If I hit Q again, currently there is the issue that it will still be selected. We will fix that later in the stop building event, but hitting the other hotkeys should already be working. So if I hit F7, wall is selected, and we actually change the state. Hitting F8 will select the stairs. Alright, so that's already working. If there are some weird things happening when pressing one of the keys, it could be that this hotkey is actually used for something else in your editor. So if you want to fix that, go to Edit, Editor Preferences, Keyboard Shortcuts, and just scroll down and check whether the hotkey is in here somewhere, and if so, just assign a new binding to that. Selecting different buildings already works fine. However, we are still not spawning our preview building. So let's add that functionality in our building manager. And the challenge that we're facing here is that we have to figure out the position and rotation of that building preview. What you can see in Fortnite actually is that the buildings line up perfectly when creating them. And that is because they are placed on an invisible grid that the player doesn't see. For us, that grid will be 400 by 400 by 400 Unreal unit. If you're wondering where that number is coming from, that is the size of the meshes we are using. So let me show you very quickly. We've got that from the starter content architecture, and there it reads floor 400 by 400. You can use any other size you want, and we will set that up in a very modular way so that you can later just change the size of your grid with some simple clicks. To create that behavior, we need a couple of functions, and the first one will deal with projecting any location in the world onto our grid. So let's go to functions, and let's call that toGridLocation. It will be asking for a location, so a vector, and it will also return a location. Let's just call that in and out. Since it only returns something, it's a pure function. Before we do the math in here, let's create some variables of the type integer. And we will call the first one x grid size, or grid size in x, whatever you want. Then here under category, you can actually put variables that would go together in a category. Just enter a text here. For example, building grid. And now that appears here. Let's add another one called y grid size. And the third one will be the z grid size. Let's move both of them into our building grid category. Compile, save. And as I said, it will be 400 for us in x, y, and finally also 400 in z. We already know that we want to make a vector for the output, and then it will give us x, y, and z to fill out. Break the input, and you will also get x, y, and z of that. And then we need a bit of math. The math for x, y, and z is exactly the same one. So I'll just show you the example of x, and then you can do the other two. So for x, we want to divide float divided by float, and we want to divide by our x grid size converted to a float. If we were doing y, that would be the y grid size, and so on. Then we want to round that, which will then return an integer, and finally multiply, so int times int, and hook up your x grid size to the multiply node. If you then convert that back to a float and plug that in for x, you projected that x value onto your grid location. Actually, the math isn't that complex. Let's just do an example. If we say that our x is 410, that would be divided by 400. So what it returns would be a little bit greater than 1. If you round that, it will be exactly 1, and multiplying it by the x grid size will mean that 410 will be projected onto 400. Basically, you now just copy these nodes 2 times. And instead of using the x grid size 3 times, you plug in the y for the second one, the z for the third one, and also hook up y from the break vector node and z from the break vector node, and then hook them up to y and z. Compile and save. That's it for the first helper function. What you also see in Fortnite is that your buildings are always rotated so that they are facing the same rotation as our player. However, it snaps to 90 degrees, so you're not able to reach any rotations in between. To do that, we'll add another function called toSnapRotation. It will also be a pure function with one input, one output. The input will be of type float, let's just call that in, and the output will be an integer called out. Because it's snapping to whole numbers, that can be an integer and doesn't need to be a float too. Let's add a variable called rotation snap. So basically the degrees we want to snap to, and that are 90 in the case of Fortnite. Also move that into your building grid category. Now again, that's very simple. You divide your input by the rotation snap, convert it to a float, then round it and multiply it by the rotation snap. Then just simply return it. What we also want to know is where our player is facing. So let's add a function called getPlayerLookAtLocation. So also give that one input of the type float that we will just call forward offset. Because you see that in Fortnite you're not simply placing the buildings exactly where the player stands, but actually a little bit more forward. So that's what this offset is for, and it will also have an output of type vector called location. Let's also make that a pure function. Simply what we do here is get our player character and get actor location, add vector. Actually, I forgot that the forward offset should be an integer in our case. Float would also work, but I'll prefer working with integer values here. And what we want to add is our forward offset, but we first want to see where our camera is facing. So off of your player character, get the follow camera, and off of it, get forward vector. Then you just multiply that by an integer, vector times int, plug in your forward offset and hook that up to the addition here. Then connect that to the output. That's it for this function. And now we will add a function that will contain all of the other ones we created, called getBuilding pause and rod for position and rotation, which will have two outputs, one of type vector called location, and the second one will be a rotator called rotation. This here will also be a pure function. And let's create some variables. First off, we need the forward building offset. Move that into our building grid category, and I'll give that a default value of 350 Unreal units. And then we also need a variable called location offset. I'll show you later when we test it why we need that. Make that a vector. Also put that in your category. We'll set the default values later. And the other variable we need is the rotation offset. You can actually make that an integer. We don't need a rotator here because we're only caring about one of the rotation axis, which is the yaw value. Pitch and roll are not important at all for this system. And also move that into your building grid category. Let's figure out the position first. So we want to get player look at location, forward offset being our forward building offset. Then convert that to a grid location and then add your location offset. Plug that in for the location. For the rotation, we get the player character, get the follow camera, get its world rotation, and then break the return value, because just like I mentioned, we only need yaw. Then call toSnapRotation, hook up the yaw to the input. We also want to add the rotation offset. And then let's call makeRotator. So roll and pitch will be 0, and for yaw we'll convert our add node here to a float. Then hook that up to rotation, compile, save, and that's it for all of the helper functions we need. So now we can turn to our events. We will start with onStartBuilding. So when we want to start building, let's check whether we are currently building. So add a branch for currently building. If it's true, that means we have to change current building. And after that, also set currently building to true. If it's false, we will just start building. And also set currently building to true after that. Okay, that's very simple. Let's do start building. So that's an extremely important event for the whole system. What we want to do here is spawn the preview of our building. So spawn actor from class, and we have to figure out that class. So get your building classes and get from that at the selected building index. Hook that up to the class. Then we right click the spawn transform and split that. So now we've got access to location, rotation and scale. Scale will always be 1, 1 and 1. But for the other two we will get building, position and rotation and hook them up. Then it will also be asking you for the resource. So to grab that we get the player character, get the resource manager, so BPC player resources, and get the selected resource. Then hook that up. Let's store the return value in a variable called current building. And what we want to do is update its position and rotation in a defined interval. So let's say every 0.5 seconds, for example, you would update that. The simplest way to do that is just set timer by event. For the event, you will add a custom event. Let's call that something like building tick. Then grab that red pin here, the delegate, and move that onto the event. Now the time here is the interval, so how long to wait before executing that event again. Let's make that a variable called building update interval or building tick rate, something like that. Let's compile, and I figured out that the default value of 0.03 seconds is working pretty fine. Also check looping, we want to execute that more than once. And the return value is actually something like a reference to the timer. So we will store that in a variable called building timer handle. Let's see what we have to do on building tick here. That's actually very simple. Grab your current building and set location and rotation. The new location, new rotation will just come from our get building pause and rot function. And that's everything for that tick event. Let's grab our event change current building here, because that's also very simple. What we do here is getting our timer, and we want to clear and invalidate timer by handle. Basically that just means stopping the timer and invalidating the reference to it. Then we also want to destroy our current building, so grab that and destroy actor. After that, set your current building to null. Basically just clearing that reference, and then we will just call start building. So that will be responsible for selecting the next building, because we don't actually want to stop building, just changing it. Let's go to our last event here on stop building. It's also very simple. We just grab currently building and add a branch. Only if it's true we want to do something. If it's true, we will set currently building to false immediately. Then call select current building with select being false. Drag in your current building and call is valid. And if our current building is still valid, we will destroy actor. And also set the current building reference to null. However, if you leave it like that, that would give you errors, because currently our timer here would still be ticking and it would try to access the current building, which is no longer valid. So we need to stop the timer before. And just drag in your building timer handle, clear and invalidate timer by handle. Alright, let's compile, save, and let's test whether that's already working. Okay, so if I hit Q, you will actually see the floor appearing and somewhat updating. However, the position looks very weird. For example, here we don't see it at all. But currently we're also able to select different things like the door or the stairs, so that's all working perfectly fine. And if I hit Q again, it will be completely destroyed, and hitting any of the hotkeys will make us go into construction mode. You also see that the rotation is set off, so it's actually not facing the player rotation. All of that behavior is intended currently, because if we have a look at our building manager, there are still two variables that we didn't set, A, the location offset, and B, the rotation offset. If we open up our third person character and let's have a look at the viewport at the mesh, you will see that by default its rotation is 270 degrees or -90. That's why the rotation of our buildings looks off currently. So let's set our rotation offset to 90, which will fix that for us. And to figure out the location offset you want to use, just drag in one of your buildings, for example the floor, and move that until it hits the very ground and looks fine for you. So in the third person example map, an offset of 140 in Z looks like it's placed on the ground. So remember that number and go back to your building manager. The location offset here in our building grid, location offset, will be 140 in Z. Compile, save, and let's see whether that's working now. So first off, if I hit F6, our floor is currently placed on the ground. Also, if I move to the left and right, it updates and snaps to different grid locations. Let's select our wall to see whether the rotation is fine too. Okay, so now that's facing forward perfectly, and if I rotate, that also rotates with us. Perfect. And finally the stairs that are also looking pretty okay and snap to the position and rotation. And finally, if I hit Q again and exit the construction mode, our building will be deleted. Alright, that's it for this episode. In the next one we will actually be building our constructions and also checking whether our resources are enough for that, and maybe also add some widgets for our buildings so we can see their health. See you in the next episode.